So guys, let's start the class. This is GATE Aerospace 2026 batch. Flight mechanics is going on. Lecture 2. So in last class we understood our strategy and we stopped our class with the idea of velocity. So we will continue at the fundamental level first. So whatever fundamental I am going to teach right now, for many of you it will be very easy. You may feel that सर क्या ही पढ़ा रहे हैं, 9th class पे आ गए. But see, when we know some subject, then in that subject fundamentals we may feel bore, but this is the style. Even tough subjects, if you start from the fundamental, it's always good, and you should not feel that heaviness, that everything should be like a flow, that everything is being simple. Okay, so you may have heard the word called rotational motion. Okay, rotational motion is very important for aerospace engineers, aeronautical engineers. Why? Because whatever aircraft we study, this aircraft is capable of 6 type of motion. Okay, one motion in forward direction, which is translation. One motion in this direction, which is again translation. One motion can go up and down. This is again translation. Okay, so out of these 6, 3 is clear. Other than that, 3 rotations are also possible. It can rotate about this angle is the pitch. This is called longitudinal axis. So it can rotate about longitudinal axis. This is called lateral axis. So it can rotate about the lateral axis. And this is called directional axis. So aircraft can rotate about directional axis. So 3 more. So 3 linear motion and 3 rotational motion. Okay, so students should be very good at fundamental level of physics. Okay, fundamental means same 9th class, 11th class, we have done our motion, force, acceleration, simple facts we have done. We will just recall them. So let's start with the concept of distance, and then displacement, and then speed, and then velocity, then acceleration, then force, and then we'll go for moment. Okay, or momentum. They both are 2 different properties. They are not same thing. That's why I have written name together, so that you can have clear picture. Moment is different, momentum is different. Okay, moment is different and momentum is different. Okay, so these properties we define when we go for linear motion. So suppose you have an aircraft. This aircraft is going in this direction. So in the beginning, this aircraft is having velocity u, that we say as initial velocity. After traveling certain distance s, aircraft will be having its final velocity, that I am saying as v. I hope you are able to relate. I have just replaced car or bike with aircraft. This is your 9th class physics, correct? So on the way you have spent some time, and because there is change in velocity, so you must have acceleration. Okay, so let's relate all those things. So what do you mean by distance? Distance means the length of the real path. So consider this as your prime example. In this prime example, what if your aircraft is not following a straight path? What if aircraft is going like this? Guys, right now I'm not teaching flight mechanics. I'm just teaching very fundamental physics. Okay, it has nothing to do aerospace, aeronautical. Okay, just recalling some fundamental concepts so that we can go ahead smoothly. Okay, so suppose aircraft is following this path. So the original length of this path, suppose I will tell you that go and purchase one rope. Okay, and you keep your rope like this. Then one student come and stand here and hold the rope. One student can come stand here, hold the rope, and then you do one thing, and straight, then do one thing, stretch the rope. So rope will be more longer. Correct? I hope I'm able to convey what I'm saying. So this is the actual length. So the actual length is your distance, right? So why distance matters for us? And if already there is distance, then why are we going for displacement? Okay, guys, I will tell you why distance matters for us. If aircraft will fly on this path, okay, then we say that suppose this whole path length is 20 kilometer. Suppose the whole path length means the whole rope length is 20 kilometer. Just feel this right now. Don't note down anything. Understand the concept. Where I'm trying to take you. You'll understand where I'm trying to take you. Okay. And what is displacement? Displacement means the shortest distance between initial and final point. The shortest distance will be your displacement. Okay, so of course displacement is going to be less than the 20 kilometer. So just suppose some 15 kilometer. Okay, so one thing is clear, your displacement is always less or equal to distance. Why equal to? Less is clear, but why equal to? What if your motion is on a straight line? Means object was here, traveled here. In that case, distance is also same, displacement is also same. So here this quantity, distance, displacement is less is equal to displacement. Correct? Now, what is the advantage of having idea about distance? Guys, aircraft will consume fuel not based on displacement. Aircraft will consume fuel based on distance. Okay, I hope you understood. Because if aircraft is going on this path, this path, this path, this path, this path, this path, so real fuel, real path, I hope you are able to understand this. But in case of displacement, the shortest path is your displacement. Why do we bother about displacement? We bother about displacement because displacement is the shortest path. Shortest path gives you idea in many different ways. When I will cover vector, then I will be giving you more better feeling, better connection of displacement. Right now, I will tell you why displacement is important. So when I will be connecting vector, that time I will be teaching some more fundamentals of displacement. Let's understand why displacement is important for us, even if we have distance. So concept of distance, you just have to note down one line: real or actual, or if you can find some more beautiful English word, length of path. This is your distance. But when you go for displacement, then you write down shortest path length. Question comes, if already distance is there, then why there is need to define displacement? Okay, I am giving you chance. If you are able to feel this, if you can create the logic, sir, there is distance, all right, but because of this situation we have to define displacement, or because of this story it's better to define displacement. Anyone of you can raise your hand if you have some idea. You can raise your hand if you before that, just hold on. Yeah, actually I found that concept library folder. So guys, whoever is the new student here, this concept library folder must be shared with you by me. Okay, in case I have not shared, just ping me after class. I will share this folder. When you go to this folder, concept library, you will be having two things: bridge course and GATE Aerospace. Bridge course is you don't have to access now, because nowadays I am taking all the fundamentals in class itself. So bridge course is that portion of the science and math what students should not miss after their 11th and 12th. It is kind of connecting bridge between your 11th, 12th and your GATE preparation. Okay, so anyway, I am teaching every fundamental in class itself, so you don't have to bother about bridge course. So directly go for second folder, GATE Aerospace. Go to GATE Aerospace. Just a moment. Camera is working well. Go to GATE Aerospace. Now in GATE Aerospace, I have every year's video and those things. You can see 23, 24, 23, 24, 25, 22. You don't watch anything else, because 26 lectures I am already sharing you directly. Okay, so 26 lectures I have not added here because I am already sharing you on WhatsApp. So not a problem, because that is easy access on WhatsApp. For me, it is very easy. I upload the video and then I share the link on WhatsApp. It is very easy for me. That's why I'm not adding here. Okay, it is for my comfort, and I feel even it is comfortable for you directly getting video on WhatsApp. So study material, this portion, this folder is important for you. This study material folder. Okay, you can access any folder, that is not a problem, but why will you access old things if already you have new things? So go to study material. Here you can see all the folders are there, aerodynamics, propulsion, this, that, all the folders are I have kept, okay, completely. So you go for flight mechanics, the fourth one, currently running fourth one. You go here and you will understand how this thing are arranged inside that. And this aircraft propulsion and aircraft structure, they are having lot of assignments, so you have to finish all the assignments. You don't have you have comparatively less assignment in flight mechanics and aerodynamics. Propulsion and structure have more assignments. And for example, when you open propulsion, how your assignment will look like? You can see AFC1, AFC2 assignment, AFT assignment, CFC extra numericals assignment, fan of flow assignment, fan of flow 2, gas dynamics, mixed flows. This kind of pattern is there. After that, assignment. Then all the books are also here. Ahmed Sayyed, Cohen and Roger, Doxon Faruqi, and gas dynamics, E. Radhakrishnan. Everything is there. But you don't have to read books and all these things. Already we have discussed. Everything I will cover in class. My only thing is this folder you should have. How will you have? I will add your email, Gmail, in this from here. This is concept library. I will go to 3 button and I will share. You can see the top share button is there. I will share to your Gmail. Okay, you can get it. Yeah, anyone is having? Oh yeah, I asked the question, so some people are raising hand. So who is this student? First one on my screen. Avnish, is that you?
Yes, sir.
Okay, Avnish, tell me, what do you feel about?
So I feel displacement is the shortest path between A and B. Like if you draw if we like when airplanes travel in real life, they don't travel on a straight line. They travel on a curved path. That curved path actually that is the shortest distance between those points and can be considered as displacement motion for that particular path.
No, you didn't understand my question. This question is for something like, if we already have the concept of distance, then how adding concept of displacement is going to help us, in what direction it is going to help us. It's very good, you have tried one question, very good. I'm not enough convinced with your explanation. No problem at all. It's good to try. Always it is good to try. Okay, Pratik, your chance.
The concept of displacement gives us the idea of like where we should head, like the direction.
Correct. Good. Only this. Yes, very good. Okay, so I got the right answer. Anyone else, if you want to say something, you can say. I will just see some more people. Arpita is there. Arpita, you tell.
Sir, can I try?
Yes, Arpita, you raised your hand, so you try first.
Yes, sir. I also have the same concept, like as distance is a scalar quantity, so we will get to know how much path we have covered. But with displacement, as it is a vector quantity, so we will know the exact position, like where we are along with the path.
You are again right. Very good. Okay, all right. So it's fine. I got both the answers correct. So I think I underestimated all of you. You all know this. So what is the physical beauty of having the concept of displacement? Suppose aircraft is here, and somehow aircraft reached here. So final location will be having this guy will be having certain coordinates. Suppose x1, y1, z1, and here x2, y2, z2. So from this to this, if we add this, gives me a vector which is a direction. So in the beginning itself, pilot or fighter pilot or in some other applications, people will come to know that in which direction we have to head. Okay, but if on the way you have hill, you cannot cross directly. If on the way you have some jungle or big buildings, so you have to choose some other path. Okay, good one. Main thing is, guys, distance is fine, but displacement we are bringing into concept of science, because we also need to bother about direction, in which direction we are heading. Okay, so distance and displacement, very simple. Everyone knows this about. Now we'll go and define speed. So speed is very simple. How fast you are covering your distance. distance. Okay, is speed is related to distance. Okay, you can have two types of speed. Yes, you can have two types of speed. One is instantaneous speed. Instantaneous speed means right now your aircraft is flying at which speed. So suppose right now on my screen 8:49 p.m. is the time. So exactly right now what is the speed of the aircraft in which we all are flying? Okay, that kind of speed, instantaneous speed. I hope you have the feeling instantaneous speed. Okay, so like suppose on the road every I mean on the runway aircrafts are standing, so that time your instantaneous speed is 0 because it is standing, it is being ready to start the rolling. Okay, ground roll. So this aircraft will reach from here to here, then it will take this takeoff, another phenomena will start. So from here to here, just to be airborne, whatever time this guy has taken, that time will tell you from 0 moment to be airborne, whatever time it has taken and whatever distance it has covered. So total distance by total time will give you second type of speed, that is average speed. Why average speed is important for us? I will tell you. Average speed is nothing but total distance divided by total time. Guys, again I am saying these things I know everyone knows, but many of us are repeating our study after so many years. So fundamentals are very, very important, and always we should start from 0. This is what I am doing. You may be feeling that, sir, this is already known to us, but similar things when I will teach in propulsion with pressure, density, temperature, different types, there you will enjoy. When same things I will do in structure, there you will enjoy. Maybe you are feeling bored because we are doing same thing what everyone knows, but it's fine. So average speed. So why instantaneous speed is important, I'll tell you. Suppose this aircraft is about to launch one missile. Okay, that time the moment missile is being detached from the aircraft, I am saying the moment missile is being detached from the aircraft, missile will be having the same velocity what this aircraft had. I hope this point is clear. Okay, so that's why instantaneous velocity is important, and speed is important. And when you talk about average speed gives you idea about many things. One very important thing I will tell you. Suppose this aircraft has to travel from city 1 to city 2, and today the aircraft is following this path, and next day satellite is telling you that no, in this path you have so many clouds and weather condition is not good, then you will follow some other path and reach here. So whatever time, whatever total distance and whatever final speed you will capture, according to that again you can find out how much fuel you have burnt. Okay, how much fuel you have burnt, again you can explain this, because actually speed is nothing but it is in background, it is related to distance. Okay, now I will come back to velocity. So when you talk about velocity, it is displacement by time. It is displacement by time. One good example we can solve here quickly. Suppose there is one aircraft. This aircraft is starting here and going here and then coming here. So this is suppose circle of radius r. Okay, so from here I can tell you speed, distance, velocity, displacement, everything. So if I tell that this radius is of 10 meter, okay, and now suppose here your speed was 100 meter per second, and here also your speed is 100 meter per second, and here also everywhere your speed was 100 meter per second. I can ask you to find out the ratio of velocity and speed, because I know velocity depends on displacement and speed depends on distance. I can ask you this. So when you are finding out velocity, that time you will bother about displacement by time, and when you are finding out speed, you will bother about distance by time. So distance by time. So you know the distance, you know the speed, you can find out time, and in same time either you follow distance or you follow displacement from point A to point B. You are going to have same time, correct? You come like this, you come like this. In both the moments I am considering that you have reached to point B. Your real path is A to B, that is curve path. But when I will calculate velocity, I will bother about the displacement, shortest path. So shortest path is your 2r. Time we don't know. This time you will calculate from here. And then you will find out velocity and speed ratio. I hope this part is clear. Because you know velocity contains two things. Because displacement contains direction, so that's why velocity contains direction. So suppose velocity, if I write like this, velocity contains two things. One is your speed and one is your direction. Okay. Based on this, suppose there is one aircraft. This aircraft is taking full turn like this. Okay, and after coming here, aircraft is going in this direction. Okay, and we found that this is the center of the circle what aircraft is turning. Okay, so now suppose here I am giving 10 meter per second, here also I am giving 10 meter per second. Then if you check 10 meter per second, 10 meter per second, your speed is not changing. But if you check the overall journey, earlier direction was this, now direction is this, direction is changed. So direction is changed. So that's why velocity will change. So I will ask you, tell me, because velocity is changing, so I will ask you, tell me what is change in velocity, because direction has changed, right? So how to solve this kind of question mathematically? Physically we understand, okay, velocity is changing, and if velocity is changing, then acceleration is also changing, correct? I'm sorry, then acceleration is also there, correct? Acceleration is also there. Let's understand how to find out. So it's very easy. First we will define our coordinate system, because direction you cannot discuss without coordinate system. You can have some popular coordinate systems. You can have coordinate system which contains x, y, z. You can have coordinate system which contains r theta. You can have r theta phi or something spherical, blah blah blah. So currently Cartesian will be helpful for us. So I will consider in this direction I have x, in this direction I have minus x, in this direction I have y minus y, and you know that to represent direction we need unit vectors. So x direction I, so minus y direction minus I, j, y means j, and minus y means minus j, correct? Concept of unit vector is very clear. So here one small concept, what is unit vector, because without this it is difficult to explain this question. Guys, unit vector we define as I, j, k. These three unit vectors we use if we have fixed direction as I, j, k means x, y, z. Okay, but other than that, if there is some important direction, that is our local direction for us, in that case you can have r cap, n cap, s cap, something k cap. We define our own. Suppose I am not at all bothering about x, y, z direction. I am doing some problem, or I am in my real life practice, I need this direction which is neither x nor y nor z. So in this case I will say n cap. Okay, for example, suppose there is a pipe. I am just trying to tell you how direction becomes suddenly important for us. So suppose there is a flow going in this direction, so this is x direction. So if the flow going with 10 meter per second, so I will say speed is equal to 10 meter per second. But if I have to tell velocity, then I will say velocity is equal to 10 into I or 10 I. meter per second. This became my velocity. But imagine suddenly different direction. Suppose I will cut the pipe like this. In that case, flow will go like this. Correct? Direction changed. This is not x, not y, not z. So locally, if I have to be comfortable, I can also write component wise x, y, but I have to be comfortable. So I will write my n direction. Okay. So whatever velocity will be there, suppose velocity is 11. So I will say velocity is equal to 11 n cap meter per second. Okay. I will come back to my original question. So we will stick at our coordinate system x, y, z. This is Cartesian coordinate or rectangular coordinate. Two names are there for this IJK system. Okay, rectangular or Cartesian. Now what to do? First you make your v1 velocity. Put vector here. What is your v1 velocity? To find out velocity, you need two things. What was the magnitude, that is called the speed? What was the direction? So speed was 10, but direction means unit vector was minus x. So minus I. This became your initial velocity. Then you go for final velocity. Again, what was your speed? Speed was 10. You can see here. It is still 10. Okay. What was your direction? Direction was in minus y direction, that is minus j. Okay. Now you can ask some fundamental question. Sir, why are you multiplying ij? Answer is very simple. To convert my scalar quantity speed into velocity, I need direction. These people are doing that. Sir, will they not affect magnitude? They will not affect, because their own magnitude is 1. That's why they are known as unit vector. So you learnt here one more concept. How to convert any scalar quantity into vector quantity just by multiplying the vector. So suppose I am telling you that I have some 5 rupees, and if I will multiply I here, it will become 5 rupees in x direction. Guys, this is called nonsense. I mean, whatever properties are defined, only those properties we can make स्केलर वेक्टर, वेक्टर स्केलर, ओके, ऑल दोस थिंग्स. ऐसे किसी को उठा के डायरेक्शन नहीं दे देंगे ना. Okay, so this part is clear. So you will find out change in velocity. So del vector v I have to find out. So always v2 vector, final minus initial is always, so v2 minus v1. So minus 10j minus 10i. So you can see here this guy will become plus. So 10i minus 10j. This became your change in velocity vector. Change in velocity vector. I hope you understood. Change in velocity vector, this 10i minus j. But this is in vector form. I want to find out how much magnitude is changing. So to find out magnitude change, what will you do? Find out magnitude of this vector. You know this, right, already. So mod of this change in velocity, that is magnitude, is nothing but whatever is your real vector. This mod I am looking for. Wait, I will just write down. If you want to find out magnitude of this vector, mod of velocity vector, change in velocity vector, you just put the coefficient and square them and add. So 10 is the coefficient of I square plus minus 10 is the coefficient of j square. You got 10 root 2 meter per second. This became mod of change. Okay, I hope this part is very well clear. Now if you want to find out acceleration, then concept is very simple. If you want to find out acceleration, so you can write your acceleration in two ways. You can write your acceleration in vector form, you can write in scalar form. I will tell you how. So in this question, if I'll give you additional data, to travel from here to here, aircraft has taken 20 seconds. Suppose I'm giving you data, aircraft has taken 20 seconds. Then what will you do? Very simple. If you want your answer in vector form, divide this velocity by time. If you want answer of the acceleration in scalar form, then divide this data, 10 root 2 data, by 20. Okay, that became your acceleration. It means there are two ways to find out acceleration. One way, acceleration in vector form. Nothing, whatever change in velocity you have got in vector form, divide that by 20. Means whole answer divide by 20. You got it? This became your answer. But if you want mod of A, then mod of V, change in V, divide by time. Simple. Clear? Just trying to recall some fundamental physics. So distance over displacement over velocity over speed over concept of time we know, acceleration we are touching now. So guys, concept of acceleration. So guys, there are two things which can change your which can bring acceleration into physics. Listen what I'm saying. There are two things what can bring acceleration into physics. So question is, what is acceleration? So your velocity can change. Okay, I understood velocity can change, but velocity can change because of two things: because of speed change and because of direction change. That's why two types of acceleration you can have. Okay, so when I write formula of acceleration like a is equal to v minus u by t, if you remember, v is equal to u plus at equation you have learnt in your 9th class. Okay, so there we find out acceleration by using your initial and final velocity, and time will be given. It means earlier velocity was u, then velocity became v, and time was t. In that phenomena, how much time is spent? T time. So acceleration you will find out by this formula. So many students may not have noticed, or you have forgot, this equation is valid only on a straight line. Only on a straight line, because in this equation we do not capture acceleration into picture because of direction change. We consider that flight or whatever is happening on a straight line. Okay, and if there is direction change, then that will become our previous case. Just now we solved that example, this example, right? So that was our direction change. So acceleration can be in the system because of two things. Now we will understand what is called momentum. Okay, not moment. Moment is different thing. Force into distance, proper distance. I will tell you when the moment will come. And momentum is different thing. Momentum is pressure into velocity. I am very sorry. Mass into velocity. Pressure is equal to momentum is equal to mass into velocity. This mass is that much which is flying. This velocity is the current velocity of the mass. This is the aircraft. Suppose mass is m. Every time fuel is burning, I am not considering that. I am considering mass is constant. Right now speed is u. It's going. After certain time, speed is changing. Speed became v. Speed changed. But mass I am considering is still constant. In real life, fuel is burning, mass will go down, but I am considering constant. In this case, you have two different momentums. One momentum is here, one momentum is here. So to change the momentum, you need force. So here momentum has changed. Here momentum has changed from this to this. It means force was there. So how will you calculate force? So from here, definition of force comes into picture. Definition of force comes into picture. Very simple way I am telling. Force is equal to rate of change of momentum with respect to time. It means how fast your momentum is changing with respect to time, or how slow your momentum is changing with respect to time. Simple. So your initial momentum was mu, final momentum is mv. So mv is your final, mu is your initial, and imagine that to have this change, you of course you will be having certain time. In zero time nothing can happen. So you took some t time. Okay, so take this common. So mu took common, v minus u by t is remaining. This became acceleration. So F is equal to ma. F is equal to ma is very popular formula, and force is equal to rate of change of momentum with respect to time. It's also right formula, but very few people remember this formula. So from now onwards, you should remember what is force. Definition of force: rate of change of momentum with respect to time. Okay, so this fundamental was important, so I explained. Now let's relate our linear physics with our angular physics. In our linear physics, we have v is equal to u plus at. This kind of three set of formulas we have, correct? V is equal to a plus at. We have s is equal to ut plus half at square. Then you have third formula, v square is equal to u square plus 2as. Remember guys, all those things I hope you know. U is initial velocity, V is final velocity, A is acceleration, T is time, S is distance. So no need to write. But when you have angular physics, then all the formulas will change. Your initial velocity will become omega naught, final velocity will become omega, or you can say omega I as initial, omega f is final. Okay, I mean to say, when you relate this, then u will become your omega initial, v will become your omega final, acceleration will become alpha, time will be time. But in linear physics you travel distance, in angular physics you travel angle, so your s will become theta. Substitute these these five people here in these relations, you will be getting your relation of angular physics, motion equation you will be getting in angular physics. Okay, now some more things we will see. In linear physics we have symbol m which will represent mass. So in angular physics we do not bother about mass, we bother about moment of inertia. So I is similar to the mass. Okay, now here we bother about force, but here we bother about torque. This torque, force gives you concept of linear motion, torque gives you concept of rotational or angular motion. Okay, now question comes directly. Listen guys, directly, just a moment, I'm getting call, I have to cut this. Directly you cannot have u is equal to omega initial, v is equal to omega final. No, this is wrong. This formula is wrong. Why? Because u is in meter per second, omega is angular velocity, radian per second. Magnitude wise they can't be same numbers. It means there is some set of rule to connect these people with these people, these people with these people. Yes, so let's understand how to relate linear physics with angular physics. Very simple. The first formula, v is equal to r omega. Okay, v is equal to r omega is the best idea. Now let's relate that. Suppose you have a fan blade and this fan is rotating. Okay, so suppose I am choosing 2 points here. One point is here at distance r1, one point is here at distance r2, full point here. So our idea is, suppose right now at t is equal to 0 they are here and the fan is turning, so it is turning in this direction and it became like this. So this point is also taking same time to reach here, this point is also taking same time to reach here. This is the similarity. One more similarity is there. This time is also this particle is also turning same amount of angle, suppose 30 degree. This guy is also traveling 30 degree. Now wait here. What is not same? This arc length is small, this arc length is big. So when you talk about arc length, it means you are talking about the real length. So distance will come into picture. So when you will relate this distance with this time, that will become velocity or speed. But when you will relate the angle with time, then it becomes omega, angular velocity. Okay, so here you understood one thing. If I say point A, if I say point B, so omega of point A is equal to omega of point B. Question comes why? So answer, theta is same for both and they both have taken same time because they both are sitting on same fan blade. Correct, point A and point B, they both are on same fan blade. So blade will turn, they will also turn. That's why omega is same. But tangential velocity of A is greater than tangential velocity of B. Why? Because radius of A is bigger than radius of B. So in real life, if you will sit on this and if you will sit on this, okay, two students will sit on this, in real life they will capture same angle but they will not capture same distance. Object B will be very fast as compared to object A. That's why when you will keep your finger near to the tip of the fan, you will cut your finger. But if you keep your finger close to the root of the fan blade, your finger will be safe. Don't try this, okay? So I'm just trying to connect and trying to give you physical feel. V is equal to R omega is the relation, okay? Now you have certain more relations. Those relations slowly we will cover. No need to cover now itself. Certain relations means you have A, you have alpha. These kind of relations are also there. You have mass, you have I. These things are also there, but only at fundamental level. I don't want to cover these two topics. In flight mechanics itself, when I will be dealing with the chapters, these people will appear. There we will discuss them in detail. I don't want to leave this as only fundamental. So when that time will come in the lecture, we will cover this in detail, okay? So guys, yesterday 12 o'clock one of my friends is having birthday, so today they are giving me dinner party. So they have reached to the hotel at 8:30 itself. I told them that by 9:30 I'll also come after class. So I'm leaving class before 15 minutes so that I can attend that, because social life is also important. So I had option to call everyone before 15 minutes, but again it will be disturbing everyone's schedule because everyone is not ready at 8:30. So I'll stop the class here itself now, and I will come back around 12 or 11:30. After that, whatever doubts or whatever will be there on WhatsApp, I will reply to everyone. So consider that after 11:30 I will start replying everyone's doubt. Thank you all. We can stop now, and good night all of you. We all can leave now.